All right, good morning, everyone. Thank you for joining us this morning. Today, we're going to have the last session, well, one of the last sessions of the RIC. Thank you all for joining us and holding on to this exciting time and topic. So today, we're going to be talking about powering up the new era of power operates. And I'm very happy to have a great set of speakers here with me, joining me on this panel. But before we get started, wanted to get a couple of logistics before we go on. So we encourage everyone to take a word. Looking forward for this session today. If you leave during the session, please do it on an open, natural break, so there is no disruption to the speakers. The Wi-Fi code for attendees is the RIC 2026, and please remember to silence your electronic devices. So appreciate everyone taking that. And then we have the QR code for questions, so we'll be looking for those questions at the end of the presentations, and we look forward for an engaging discussion during that. So again, my name is Ida Rivera. I'm currently the acting director in the Division of Operating Reactor Licensing in NRR. I have been with the agency for 24 years now. I look forward to this discussion today. We have been leading the effort for getting ready for power operates. We have been working effectively on ways on how we can increase the clean, reliable electricity from the existing nuclear fleet. Over the past 2 years, we have been working with the industry, and over the past 2 decades, we have been already approving and working on power operates, and including the added 1,000 of megawatts to the grid, while continuing to maintain the highly safe standards expected of the industry. Today, we're entering a new phase. Electricity demands, as you have heard, is growing. More sectors of our economy are relying on the electricity, and there is an increasing interest in maintaining and maximizing the output of the existing fleet. As a result, many of the plants across the country are once again looking for opportunities for power operates. Over the past 2 years, NRC have been taking steps to make sure that we are ready for this new wave of applications. We have been working with the industry and other stakeholders to streamline our review process, update guidance, and other stakeholders to strengthen our coordination across the technical disciplines so that we can review the applications both efficiently and rigorously. Today's sessions is going to highlight the progress and bring together perspective across the industry. This session is scheduled from 10:45 to 12:15. We will have each speaker present their views, and at the end, we'll have some time for questions. During this session, you're going to be hearing presentations on an update from the NRC on our readiness for power operate review, Department of Energy perspective on their role of updating and providing efforts on operates in meeting the future energy needs. And then industry perspective, including power operate plans from Duke Energy and Southern Nuclear Company. Our first panelist here today is Mike Mahoney from the NRC. Mike is currently the acting chief of the Plant Licensing Branch 4 in the Division of Operating Reactor Licensing in the Office of Nuclear Reactor Regulation. Mr. Mahoney started the NRC in 2008 and has served as a technical assistant and is senior project manager in Doral, and is the subject matter expert in power operates. Our second panelist is Dr. Rian Baran from the Department of Energy. Dr. Baran served as the Deputy Assistant Secretary for Nuclear Reactor, overseeing the comprehensive portfolio that includes research, development, and deployment of advanced nuclear reactors, as well as cutting-edge technologies that underpin the technical and economic sustainability of the nation's current commercial nuclear fleet. Dr. Baran began his career at Los Alamos National Laboratory, where he spent over a decade of an experimentalist and program manager. Dr. Baran also served as the Assistant Director of Nuclear Technology and Strategy in the White House Office of Science and Technology Policy, leading policy development and issues related to nuclear fission and fusion energy, national security, and emergent technologies to enhance resilience and bolster global competitiveness. He holds a PhD degree in nuclear science and engineering from Rensselaer Polytechnic Institute, RPI, in Troy, New York, where his doctoral research was funded by the U.S. Naval Reactor in support of the Knowles Atomic Power Laboratory Advanced Reactor Program. He also earned his dual BS in nuclear engineering and engineering physics from RPI. The third panelist is Christopher Smith from Duke Energy. Chris Smith is the director of Duke's Energy Strategic Capital Organization, responsible for the fleet's power operate and 24-month fuel cycle programs. Chris brings over 17 years of experience in the nuclear industry, having worked across operations, engineering, maintenance, and training in both boiling water and pressurized water stations. He was a 2013 WNU Summer Institute Fellow, holds a mechanical engineering degree from NC State, and previously held a senior reactor operator license. The fourth panelist is Thomas Kindred from Southern Nuclear Company. Tom has over 20 years of experience in the commercial nuclear industry. He started at Westinghouse performing reload and startup physics, testing safety analysis in support of the original PWR upgrade programs. He spent 5 years at the EPRI in the Risk and Safety Management Program, participating in the Japan National Project for post-Fukushima decommissioning activities, with particular focus on severe accident research and learnings. Tom joined Southern Nuclear Company in 2020, and where he serves as a consulting engineering role and has worked within the fuel safety analysis and risk areas, leading initiatives to accomplish plant operates, cycle extensions, and integration of accident-tolerant fuel systems. Tom holds a bachelor's in the nuclear engineering from Missouri University of Science and Technology, a master in mechanical engineering from Carnegie Mellon University, and professional engineering certification. Please welcome our panelists, and first, I'll turn it over to Mike.
Thank you, Ida. So again, as Ida mentioned, my name is Mike Mahoney. I'm the current acting branch chief in Division of Operator Reactor Licensing, or DORAL. I'm responsible for the Region 4 plants. My normal job is a senior project manager and the subject matter expert for power operates. Next slide, please. One back, sorry. Yeah, there you go. So just a little background on power operates. So the NRC regulates the maximum licensed power level at which a nuclear plant can operate. This power level forms the basis for many of the plant's analyses that demonstrate safety. The change in that increased power level is called power operate. Three types of power operates. Measurement uncertainty recapture power operate, or MUR, which is typically less than 2%. These rely on improved feed water flow techniques that allow more accurate determination of reactor power. Some licensees are now planning to use a new methodology supported by a recently NRC-approved topical report from Electric Power Research Institute, or EPRI, on data validation and reconciliation methods, or DVR. The second type is stretch power operates, typically up to 7%. These are within the design capacity of the plant and usually involve adjustments to set points and not major plant modifications. Extended power operates, or EPUs, are larger increases, in some cases up to a little over 20%. EPUs require significant upgrades to major balance of plant equipment, such as turbines, pumps, generators, and steam dryers. Since approving the first power operate in 1977 for Calvert Cliffs, the NRC has approved approximately 172 power operates. To prepare for this next wave of applications, the NRC formed a working group in early 2024 to identify potential efficiencies in the power operate review process. In February of 2025, the NRC issued a regulatory issue summary, or RIS 2025-02, requesting voluntary information from licensees regarding their power operate plans. This early communication supports resource planning and work prioritization. We appreciate licensees have responded. The consolidated responses to the RIS are now posted on NRC's public webpage under expected applications on the power operate website. And as you can see, we're expecting power operate license amendment requests for 30 units from later in 2026 to 2032. Licensees who have not responded to the RIS are still welcome to respond, and again, I'll reiterate, these responses are purely voluntary. Next slide. So this slide just shows the same data, if you will, but presented in a different format, Gantt chart. And you'll see the overlap of power up rates that'll be under review in the next coming years. As I mentioned on the last slide, we formed a working group 2024, and consistent with the 2024 Advance Act, the staff has been identifying opportunities to improve, streamline, and modernize the review process. The working group identified 3 main areas to improve the process. One was continued stakeholder engagement. We've had multiple public meetings in the last year and a half, and we continue to plan public engagements. We've developed a graded approach for power uprate reviews, which I'll discuss in a few minutes. And then we've also, the third area was to work on targeted improvement areas. In September 2025, staff issued draft guidance on the graded approach for power uprate reviews, and we held a public meeting December 11th and 12th to discuss this guidance. The purpose of this framework was to provide a risk-informed method for determining the appropriate depth of review for each submittal based on technical review area. The intent is to focus staff resources on where they matter the most to risk and safety while maintaining reasonable assurance of adequate protection. We continue to refine the guidance based on stakeholder feedback, and we'll further refine it based on lessons learned as we start to receive applications. Next slide. So just want to touch on some of the completed actions that we've completed in the last year plus. So as mentioned, the issue of the RIS and the responses to the RIS, and this is important to assist NRC to effectively review the projected applications that are coming in. We've obtained alignment with Advisory Committee on Reactor Safeguards, or ACRS, on which power uprates may be reviewed by the ACRS, and we continue to engage with ACRS on planned uprates. Staff issued an internal memo delegating signature authority for all power uprates at the Director of Division of Operating Reactor licensing level. Some of them extended power uprates were signed at the office level, so this provides some efficiencies to have all uprates signed at the same level. We've updated the public web page to have all requests for additional information that the NRC asked and licensee responses to these REIs for all previously NRC-approved EPUs. And as I mentioned, we've had multiple public meetings and workshops to get stakeholder feedback, and our next meeting is actually next week on March 19th. Next slide. So I'll touch on a few areas that are in progress now. So again, the graded approach, we continue to refine the guidance based on internal and external feedback. We're working on developing safety evaluation templates, and specifically we're looking at developing templates for a bundled application. So we've heard from the RIS responses and other communications that for boiling water reactor EPUs, many of them will come in with using the maximum extended loan line limit analysis plus, or MELA plus. And so we are planning to standardize and streamline our safety evaluations. We're developing internal dashboards to support resource plannings, and these are mainly from responses to the risks that we get, and so we've used them to develop dashboards for planning purposes. And then the last thing I'll mention is we are exploring ways to incorporate AI to support but not replace staff reviews, and I'll touch on that in a little bit. Next slide. Executive Order 14300 establishes what I'll call a 12-month backstop for NRC reviews of operating reactor licensing actions. And this aligns with our current targets of, for MURs, 6 months review, NRC review, SPU 9 months, and EPU 12 months. I'll just note these review targets also align with review targets that were provided in a May 2024 letter from the NR Office Director to the Nuclear Energy Institute, or NEI. And I'll mention that these timelines are after the NRC accepts the application for review. Next slide. So I just want to briefly talk about how we're looking at AI for power uprate reviews. And again, I'll mention this is to help assist and support the staff not complete the reviews. Staff is using NRC's AI tool called Simplify, which was developed by the NRC's Office of the Chief Information Officer. And there's 2 main areas that we're looking at it. One is from a project management perspective, or PM. And some of these items are to support initial support screening, acceptance review screening from a PM perspective, generated draft acceptance review letters once the application has been determined to be accepted, identifying which technical branches should be engaged based on the contents of the application, providing plant summaries to help technical staff quickly orient themselves to important plant characteristics. And one thing I think that will really help is summarize in different parts of the application. Historically, some of these EP applications are thousands of pages with 20 or 30 different attachments, and this could assist reviewers to easily find their relevant technical areas. And then one area we're starting to explore is using our draft graded approach for power uprate guidance to support initial screening of incoming applications. From a technical reviewer perspective, we're looking at comparing applications against relevant precedents, exploring whether previously issued REIs have been addressed, extracting and summarizing information from plant licensing bases, and exploring AI's ability to assist in the development of the safety evaluation templates that I previously discussed. I'll just note we're also engaged with the Department of Energy's Light Water Reactor Sustainability Program on potential uses of AI. Next slide. So in closing, the NRC remains committed to improving our review processes so our efforts reflect the best use of staff resources and commensurate with safety and risk significance. Our preparation strategy will support licensee schedules while continuing to assure reasonable assurance of public health and safety. We will continue to engage with stakeholders, including the next public meeting on March 19th. And we also encourage licensees to engage staff in pre-applications meetings, particularly to discuss some of the technical areas that historically required significant resources. For example, steam dryer adverse flow effects, containment accident pressure, and transient and accident analyses. And other areas to gauge staff potentially is to discuss how the draft graded approach can be applied to applications to streamline review. Thank you for your time. I'll now turn it over to Dr. Baran from Department of Energy.
All right. Good morning, everybody. So I want to start off by thanking the organizers. I was here on Tuesday. I got to kind of open off a session, and so it's been a really, really great event. It's been a great RIC, so I want to thank the NRC and the folks that did the organization. I want to thank the folks that are here that have stuck it out till the end. Thank you for your interest in Uprates. I want to thank my team. Chris Bunting is here, who leads all of my activities in the Office of Nuclear Energy for the current fleet, including on Uprates, the performers at Idaho National Laboratory and across the laboratory complex, but more importantly, industry. I think for us, the President's May 23rd executive order gave the administration, gave the executive branch a North Star of what to target as it relates to how many gigawatts we need to deploy. And it was 400 gigawatts by 2050 of new nuclear. And we don't have an official government position on how much you need, let's say, notionally by 2035, but just an extrapolation. I'm a scientist, right? Let's just say 50 gigawatts by 2035. If you think about how to get there, you're going to need to have gigawatts on the grid, so gigawatt plants, SMRs, and certainly uprates and restarts are going to be an important component, right? We know what the ceiling is, and that is the fastest way to get gigawatts on the grid. And so, I am really excited today to announce that the Department of Energy is launching Uprise, which is really for us a groundbreaking initiative to accelerate domestic energy production. I have a graphic here that should kind of explain to you what Uprise is. But for us, it's really three things. Number one, how do we work with industry and work with, of course, not just the utilities, but ultimately off-takers to be able to accelerate uprates and restarts, right? That is the fundamental goal. How do we unlock that type of offtake? And how do we bring our credibility, our technical analysis, the work that we're already doing with industry, that we're already doing with the NRC, how do we accelerate that to accelerate the amount of gigawatts that we can put on the grid under Uprise? So, for us, we're I think that Light Water Reactor Sustainability Program was mentioned. This is a program that does extensive work with industry and has been for a long time. And so I'm going to talk a little bit about the different components. We note there that, of course, it's not just bringing together industry and off-takers. I do explicitly have the Energy Dominance Financing Office. This is the artist formerly known as LPO. They are also an important partner in this, in their ability to provide loans for things like energy dominance, and for them, Uprates is also an important priority. And so I wanted to make sure that I highlighted their participation in this. And so for us, I think the ultimate goal is let's accelerate the sprint activities that we have been doing, the things that we've been focused on related to supply chain readiness, related to technology deployment, related to the investor-grade techno-economic analysis that we have been doing, that we'll continue to do and accelerate to help get gigawatts on the grid faster. And let's take all that and let's work with industry, and let's do some convening and let's do some matchmaking, and let's try to see how we can actually accelerate. So that initiative is launched today. I think you can go to our website. The sequencing between me speaking and it being posted, I think, is in a matter of minutes. So you can read a little bit more. But my hope today was to walk you through some of the specifics here that is, one level deeper than the press release. So I mentioned our primary goal, and the NRC made a great presentation. I think we have a good understanding, if you go to the next slide, of what is in the art of the possible for uprates and restarts in terms of gigawatts that could be obtained from balance of plant improvements, from physical uprates, and from restarts. And we think we have a good understanding of what the utilities are planning on doing right now. And the President's executive order on May 23rd said 5 gigawatts by 2030. Well, under Uprise, we want to surpass that. We want to get to 5 gigawatts by 2029 and 2.5 gigawatts by 2027. And the goal here is to work with you collaboratively to make that happen. I think we all, as Americans, at the end of the day, have the same commitment to try to get energy on the grid to unlock affordability for our own citizenry, right? So this is not just a matter of administration priority. This is a matter of societal importance, and so we're looking forward to working with you all. But this is the ambitious goal that we have. And we do think that, let's just talk about balance of plant improvements by 2029. This is repair or replacement of moisture separator reheaters, increasing capacity of main steam condensers, cooling systems, underperforming feed water pumps. We have a good understanding of what is required technically. The NRC has presented an important, their work in streamlining how they do the licensing review. So they're not going to slow anything down. You heard the chairman's remarks earlier this week about how success for nuclear entails shovels in the ground. Safety and security is paramount, but shovels in the ground. Uprates is not exactly shovels in the ground, but in my mind at least, it is in the spirit of what he was talking about. How do we get gigawatts on the grid? And so for us, I think we've been working hand in hand with NRC as an incredible and important partner on this and other topics. And so we understand the technical capacity there. And what we can do is, in addition to helping build the business case, right, which I know industry is doing as well, but for us, we want to be there with you and helping take that technical work, build the business case, understand the supply chain, what's ready, where the impediments are, and let's figure out how to work together to actually accelerate. Next slide. So I talked about the supply chain piece, and there's a lot more that I can unpack. The safety margin and the technical work that underpins the capacity that can be unlocked there, and then of course the business case. By the way, including looking at things like behind the meter. What is your allowable cost if you are pursuing a behind the meter approach, right? All of these things together, they're all, I won't say disparate, but certainly there's a lot of extensive work that is being done at every level of government and industry, and so our goal is to pull it all together and move faster. I will note, if you want to go to the next slide, NRC had a good preview of some of their AI work, In our office, I think all of you have hopefully heard about the Genesis mission and some of the work that we're doing to ensure that AI is not just an uplift for the work that we're doing, but can be transformational for nuclear energy deployment. That does include for things like uprates and restarts. I'll note that before there was a Genesis mission, that the LWRS program and the team at Idaho National Laboratory and across the DOE complex has been looking at ways to not just use AI to improve how we look at the different parts of the sustainability or the optimization of reactors, but truly transform and add speed and scale. So I'm really excited about that work. They've been doing it hand in hand with the NRC. We have a special relationship with the NRC, right, as both federal entities working together, including on AI. You know, we have the ability to quickly prototype and develop the tools, and we similarly have access to a lot of information that allows us to optimize those abilities. And so a lot of kudos to the teams that are working on this. That is a component of acceleration. It just happens to be a component that I personally believe in as a heavy user of frontier models and artificial intelligence in my personal life. I do believe in the transformational nature of it. So it's quite exciting. And I won't go into the details about the licensing challenges that can be overcome. I think the NRC did a good job of talking about their structure and how they're thinking about this. But what I want you to take away, if you're not a big AI user, and probably at this point many of you are, I think you should understand that our perspective is this will be a key component for acceleration of nuclear gigawatt deployment, including in the context of uprates and restarts. Next slide. So I just want to end by talking about the Limerick Digital Control System. I was happy to see the chairman include the approval of the system upgrade as a major accomplishment of his remarks on Tuesday. And this is something that's been a significant effort in collaboration with the NRC, utilities, the national laboratories, and it demonstrates what we can do when we work together. My boss, Ted Garish, the Assistant Secretary for the Office of Nuclear Energy, when he talked about this project, he talks about how it spotlights the important ongoing operation of our current fleet and the importance of upgrading our power plants with digital systems. So for us, we know that upgrades is not uprates, but this is for us a way to showcase how we can do things that are new and different, and how it highlights kind of a whole of government with industry together. So I wanted to highlight that, and then. Finally, and I'm going to look forward to the questions and answers. I'm glad that we have not just the NRC and DOE here, but we have our colleagues from the utilities as well that are thinking about this every single day. And so I'm looking forward to hearing their perspectives, because ultimately we have to do this together, and I'm looking forward to the continued and enhanced partnership. Thank you.
Thank you, Dr. Perron. My name is Christopher Smith. I'm the Director of Strategic Capital with Duke Energy. It's an honor to be here today. I want to start by saying thanks to really everyone at this table. The collaboration that we have seen thus far on the journey, though we're early, I think is a great early sign and leading indicator of what we can accomplish together as a united front deploying new nuclear megawatts to the grid. When I think about the opportunity in front of us, once in a generation or once in a career is the term that I like to use with our team. When you look at the staying on top principles that Chairman Nee mentioned in his opening remarks on Tuesday, there's opportunities to touch all of those with these uprate projects and deploying short-term megawatts onto the grid. Excellent standards and leadership and talent development stand out to me. It's a great opportunity to develop the workforce, the supply chain, all the piece parts, components that 10 years from now we can utilize those skills, and this is a springboard to deploy new nuclear in this country. Well, when we think internally about this, the legacy of our operating fleet and the sustained reliability of it is table stakes. We cannot impact the reliability of our operating fleet with any of the power uprate projects that we're implementing. And I would challenge with the goals that we just saw from Dr. Baran to deploy 5 gigawatts by 2029. That should be a standard that we all set. Just a 1 or 2% decline in existing fleet capacity factor with uprates could get us nowhere if this is not done correctly. Tomorrow, as I mentioned, extending the operating cycles of our entire operating fleet, all 11 units with Duke Energy, as well as safely maximizing power output through uprates is the near term. We also intend to extend the lives of all 11 of our units to 80 years of operation. Then, as I mentioned, for the future, how we execute this will determine our ability to execute new build. Next slide, please. Our plans, which stretch out through 2031 currently, essentially total the output of a small modular reactor. So in a lot of ways, when you think about the work in front of us, so it's distributed, it is cost competitive and relatively simple to deploy compared to new build, and we can achieve, again, the equivalent of one SMR across our fleet. Brunswick, 2 units at Brunswick plant, we intend to proceed or pursue measurement uncertainty recapture, MUR uprates there, utilizing the DVR technology that Mike Mahoney mentioned earlier. We'll have those megawatts on the grid by 2029. McGuire and Catawba nuclear stations, we intend to add 75 megawatts per unit. We're considering those extended power uprates about 7% and significant balance of plant modifications required to achieve those. And then in 2024, we did achieve measurement uncertainty recapture uprates at all 3 units at the Oconee nuclear station. Next slide, please. 24-month fuel cycles are interspersed, as we'll see in a few slides, over top of the power uprates at our fleet. When we look at the opportunity of doing these projects together, some of the synergies that can be achieved by touching calculations, documents, the plant one time versus multiple times, we think that's a key benefit of the schedules that we have laid out. I will say, though, it's important, again, when we think back to quality and achieving excellence, each piece of this puzzle must be done with rigor, as we expect in today's operating fleet. Next slide, please. We're utilizing a milestone view to look at overall program progress. So when you look across the industry, we have a history of executing component replacement projects, typically in discrete chunks. Projects typically done in a refueling outage. On occasion, it may stretch over a couple of refueling outages, but a long-term view of 5 years of tasks that need to be executed in a specific order to achieve a specific outcome. We're utilizing this program milestone view. Again, this is a great communication tool when you think about our organization supplementing the sites in our operating fleet. This is a great tool to communicate progress on these projects to various stakeholders. Next slide, please. There won't be a test on this afterwards, but this is a great visual to show just in the Duke Energy fleet the string of licensing submittals that are required to achieve the goals I just mentioned. So again, this is something that we have been and intend to stay very transparent about with IDA, Mike, their organizations at the NRC. They've been very productive conversations. But this chart really, to me, highlights the importance of early open communications and preparation. The dominoes here can fall correctly, or if they don't, you could see there's risks that could be provided there. So again, preparation defines outcomes. So doing everything we can as an industry, as a licensee, to work with the NRC and convey our desires and also work through the process we're willing to do to achieve these outcomes. Next slide. And I'll end touching on 2 things that have already been discussed. A couple keys that we see to success. LIC 112, the power uprate process, Mike mentioned the next public meeting on the 19th on this. the graded approach binning, we believe, is going to be key to achieving the licensing timelines that have been laid out. So again, collaborating on that document, on the binning of the first submittals, and being receptive to feedback and open there is going to be a key driver of outcomes to achieve the revised licensing timelines. And then Dr. Braun mentioned the Uprise movement as well. Acceleration is a word that comes to mind for me. There's a lot of collaborative industry groups. When I think of the PWR and BWR owners groups, NEI, EPRI, certainly others, what can be done to accelerate the great work that's been being done across the industry, and then really make sure we're coordinating and collaborating in the right ways so that we're not duplicating effort, but at the same time we're achieving some amount of acceleration than we would otherwise see on our own. And then moving the needle on supplier capacity and quality. I know there's been many discussions. There was a session this week on this, but it's a muscle memory that, quite frankly, in the industry, we haven't needed to have. We've done it in the past when you look through deployment of the existing fleet, but it's largely a new generation of workers. So how do we execute on the supplier side? And when I say resources, I think people as much as components will be critical, again, when we think to executing with excellence. And I want to close with something that stood out from Admiral Willard, IMPO CEO, that he said yesterday. Have we done this before? We've done over 170 power uprates in the industry, but I would argue, as he did, that sustaining the existing fleet reliability through it has not been done before, nor have we had the fervor associated with new deployment on the horizon as well. So again, it's our intention to stay focused on excellence in execution, one step at a time, and preparation will determine outcomes. Thank you all.
Good morning, everyone. Can you hear me? Good, loud and clear. I want to thank Ida and Mike for having me, giving me the opportunity to speak today on your panel. And Elena, you know, she's been the one wrangling us, trying to get slides. You know, she's sitting over there, but just want to thank her as well. For all of you, I want to say congratulations. You've made it. If you're in this session, I think this might be the last presentation you have to sit through today. So congratulations on that. Good morning, my name is Tom Kindred. I'm a consulting engineer in the nuclear fuels and analysis area at Southern Nuclear. Today I'm going to talk about why uprates are important to SNC's fleet of operating reactors, what we believe are key and significant improvements that are needed in the regulatory framework to achieve these uprates. We'll briefly discuss how we'll use innovation, specifically AI, because everyone's talking about AI, and I wanted to get a chance to do that too. To improve our efficiencies associated with achieving our capacity increases, and we will reiterate our needs for the near term to deliver on our commitments to the owners of our impacted assets associated with these uprate expansions. So this is going to be long-winded, and I'm sorry, but why are uprates important to SNC? Across the Southeast, Southern Company and subsidiaries have been delivering on the President's energy plan or vision for energy independence and energy dominance by providing our customers with reliable and affordable energy that supports economic growth. With the recent and projected extraordinary increases in load demands, we have responded by rapidly expanding all aspects of our system by optimizing our existing infrastructure as we invest reliably in serving our communities. But it needs to be very clear that meeting these load demand increases with the capacity increases will not come at the expense of affordability to our consumers. That will remain a top priority for Southern Nuclear. Under the careful oversight of our state public service commissions in Georgia, Alabama, and Mississippi, Southern Company's electric operating companies holistically plan for all aspects of the energy value chain, which results in our companies choosing the least cost, most reliable energy solution to serve our customer needs. In short, the least cost, most reliable, even though we have done uprates, but maybe it has sacrificed reliability. If anybody looks at IMPO 9602, we do know how to do these. This is the least cost, most reliable way to increase our expansion, or to expand our existing infrastructures. And that is why the uprates that we have planned are important to Southern Nuclear. Next slide, please. Oh, previous slide. We were one ahead. That was my introduction slide. Thank you. So the figure on the left is from an NEI report, and it kind of bins where we can get these capacity expansions for the existing fleet. You have things like the plant restarts, Palisades, Constellation's working on a restart at one of their clean energy centers in Pennsylvania, fuel cycle extensions. So even though, and that's really for PWRs, I think most boiling water reactors have gone to 24-month cycles. But if you can go 24 months between refueling, shutting down and refueling, your integrated energy production over that time frame is larger than if you had to shut down at 18 months for 30 days or whatever to do a refueling outage. So cycle extensions will increase our capacity to put megawatts on the grid. The lion's share, however, from that figure is in power uprates. And how S&C plans to contribute to that vision and the President's vision of energy dominance and independence, we plan to uprate Alvin Vogel units 1 and 2 by both units by 3.4% to 3750 megawatts thermal. We plan to uprate our plant Hatch, which is BWR 4 power plant, to 2960. In total, it's coming out to about 640 megawatts thermal, around 210 megawatt electric capacity increases, and we plan on doing that by the end of the decade. I will say the disclaimer, any plans related to EPUs will be made through constructive state regulatory processes to ensure we have the right mix for all of our customers. We're a regulated utility. Anything we do that requires this type of investment, we'll have to get approval from our utility frameworks to do that. Next slide. So on this slide, I really want to highlight the interactions, the collaborations, the activities that have occurred over the last 2 to 3 years. I've had the pleasure and the opportunity to get to be, integrally involved, I guess, personally involved, however you want to say it. I've been at, pretty much every one of the workshops, presented at many of them, and I will say, what we've experienced in the industry, and at least from S&C's perspective, we have witnessed a fundamental change in the interactions between the Commission and the industry as a part of these workshops. The industry is the Commission's reaching out, asking for external stakeholder input to help advise and inform the development of these rules. In the past, the rules would be developed, the industry wouldn't have a chance to provide, what they would like to see in the rule, guidance that they may need. The rule would get released, it would take years, and I'll give you an example. Reg Guide 1183 Rev 1, the draft guide was released in 2011. I believe it was approved in 2023. It took 12 years to release a reg guide, right? What has happened in the last 3 years and this paradigm shift in the NRC's behavior has accelerated beyond any of our imaginings, anything we could ever imagine. We've accelerated the development of this massive rule that's going to set the stage and change the future of our industry. Particularly, we want to highlight, and we believe it improves regulatory transparency. Seeking those external stakeholders improves that transparency. At S&C, we do the dose analyses in-house, so we have Reg Guide 1183 up here. It's to highlight. But for instance, there's significant improvements in modeling realism for these reg guides. Without it, I don't know how we would accomplish our uprates that we have planned for our units, right? This improved realism, or as I think some folks said in their open plenary, reduction of unnecessary conservatisms. I think you could say it either way. But that improved realism in BWR streamlined pathway modeling, BWR suppression pool modeling, which the industry has been asking for about 30 years. Among other things, there's true risk-informed elements contained within that reg guide, frequency, consequence, performance-based aspects that utilities can leverage. It has all of those things, everything we would like to see, things we've been asking for a very long time. We would also like to thank David Luxett and the Melcor team at Sandia. The DOE's world-class researchers have developed these models on an accelerated time frame in conjunction with support of the Commission and NRC research to deliver the industry this much-needed guidance. It's extremely important what is in these reg guides and the guidance that's coming out to support these rules, and it's going to be very valuable for the industry. So thank you. Lastly, the binning improvements. So the LIC 112 binning approach, we believe, is going to have significant improvements in durability and predictability of our EPU submittals. And it's also, we believe, comparing previous precedents like Peach Bottom, being able to have allowances for bundling and streamlining that is going to reduce the implementation timeline of our power uprate submittals by years, literally years. The case study we looked at, I think, was on the order of 36-month reduction in implementation timelines. That's huge, right? And we're getting, feedback. Sorry, this came in during one of the sessions yesterday, but the feedback on the applications of the LIC 112 bidding approach to non-EPU applications are yielding 40% reduction in review schedules, 45% reduction in review effort, 47% reduction in review durations, 90% of the non-EPU reviews have been completed ahead of schedule. This provides a promising future for our implementation plans for our EPU submittals. Next slide. All right, everyone's talking about AI. I wanted a chance to talk about AI today too. So I apologize for the small print on the screen, but we are working to leverage AI to improve innovation and efficiency in the development of our EPU submittals. I asked the AI, or I had actually Jeannie Johnson, one of our licensing engineers, ask the AI to summarize the current licensing basis, power levels, and history kind of chronologuing of Hatch and Vogel, and output that in a table format, integrating our plans for our future EPU submittals. Now, I know how long it took this because in pilot workshop slides, I generated this table by hand, looking up SERs. It took more than minutes. AI did it in seconds. It generated the table, the slide, the image on the right on slide 2, the table that was generated by AI, then AI rendered that image that chronologued all that into beautiful graphics, and it did it in seconds. We're still working on it, right? AI, everybody's working on different aspects, but we believe leveraging it in this way, training the large language models to understand our design and licensing basis is going to significantly improve the efficiency in the development of our submittals, but also, and it was touched on by one of the other panelists, we believe it's going to significantly streamline the onboarding of new engineers to support these projects. These are massive, EPUs are massive projects for a nuclear utility. I think it's probably the biggest project you can ever ask a nuclear utility to undertake. And so we're going to have to onboard engineers, get the workforce trained up, familiar with our licensing and design basis. And we see AI as a very innovative tool to do that. Now, my VP of Reg Affairs, Cheryl Gayhart, is in a parallel panel. She's probably doing a much better job explaining AI to me than I am. But I know everyone wants to know about AI, but I've only got one more slide, so please don't leave. One more slide and we'll be done. Next slide, please. I just want folks to take a few seconds to study this slide, and then I'll talk about it. I did a Google search in preparation for the slides, playing with Copilot, trying to learn how to use AI better. I asked it to summarize the benefits of the increased enrichment rulemaking. That's what we called it. It's since evolved into the rulemaking to support EO 14300. At one time, I think it was called the Omnibus Rule. It's been called several things. But one thing, it said a bunch of stuff about improving fuel efficiencies and all that. But one thing it did say, the ongoing discussions and proposed changes are expected to shape the future of nuclear energy in the United States for years to come. And I thought back when Chairman Nee's opening plenary remarks about this is a career-defining moment for the Commission, a once-in-a-career change. It's probably once in a career for the industry. I agree with what Chris had said in his presentation. We are here. We are at this moment. And what we really want to capture with the slide is that we wouldn't have gotten here. I don't believe we could have gotten here without the collaboration of the entire industry working together. For those of you that were in the fuel session, Nathan Capps from Oak Ridge talked about how the Commission, working with the labs, doing research, developing technical bases, the NRC reaching out for external stakeholders to get the input on the rule to inform the development of the rule. You had DOE researchers at Oak Ridge, PNL, INL, missing one, Sandia, right, doing all this stuff, all working together, EPRI coordinating and performing research, leading in conjunction with the DOE, the collaborative research on advanced fuel technologies. That's a lot of the stuff that was done and talked about in the previous panel was done under that. All being coordinated by the Nuclear Energy Institute. Al Santos at NEI, I don't know where we would be if you had not led this. I don't know how you brought us all together in the way that you did, but thank you. We are where we are on the edge of the future because of this collaboration. This is the future that we need to maintain, and I will say, owners groups, I'm sorry, you should also be on here. The BWROG and the PWROG, Bree Sarkea and Brian Mount contributed significantly in the years leading up to the rule. But where we find ourselves is on the edge of the future. The future is right here in front of our face. And if I can leave you with one thing, if you want to forget everything else except AI because it's awesome, don't ever forget about AI. Everything else I've said, the one thing I would like to reiterate today, the R word's been used a lot. Those of us that lived through the first, we'll call it, I won't use it. I made a pact with my colleagues and peers that lived through the first one. I won't use it. It has a synonym. We can say it's resurgence. You know, we won't use it. If I could go back and say what would be one thing we should do different or do better at as an industry, it's delivering on our commitments, doing what we say we're going to do when we say we're going to do it. We need to, in this time, for this R word that we're moving into, and I'm optimistic, right? Don't want to jinx it, but I'm optimistic. You know, for Southern Nuclear to deliver on its commitments, the commitments it's made to our public service commissions, the commitments we've made to accomplish these capacity increases, EPUs, to the owners of our plant assets, for us to accomplish those things when we say we're going to accomplish them. Timely completion of the rule supporting EO 14300 has to be performed along its current schedule before the end of 2026. And that is all. Thank you.
All right, thank you all for your great insights and discussions today. And Tom, just to let you know, we are committed and we are ready. We are delivering those rules, and we're going to be by the end of the year. So,
Ida, if anything I've learned in the last 2 to 3 years, I completely believe you. I believe the commission is ready, and I believe they are going to meet the needs of the industry. They are going to preserve safety while enabling the future.
thank you. All right, so we have been, here's the QR code. If you have not been able to submit your questions, we have received a couple, and I'll start with this ones, but so the first one is, Mike, you got the first one. Do MURs warrant a regulatory engagement plan? And is that really a complex EPU and new reactor licensing? And maybe we can start with regulatory engagement plan. I don't think that we have talked about that, but I'll let you.
Yeah. So I'll say for MURs, I don't see a need for an actual regulatory engagement plan, but I would say for MURs to engage with staff for pre-application meetings. We haven't done an MUR for a little while. Coney was the last one, so I don't think a regulatory engagement plan is needed. However, for MURs, I will say that for the March 19th public meeting, that is an area that NEI plans to discuss, more related to EPUs and the larger uprates.
Yeah. And just for additional context, we have been talking about regulatory engagement plans. As you saw from Duke's slide, there's a number of license amendments that would need to come through before they actually get to their EPU LAR submittal. So we are trying to work with the industry to see what the strategy is for each particular site, and we're calling that a regulatory engagement plan so that we can understand and plan our resources for those activities. So, all right, next question. Let me see. I'm going to go to another. Dr. Baran, this one is for you. Does the DOE recognize that although there has been improvement in the licensing efficiencies, there is still major issues and backlog with the reviews and regional transmission grid owners have to do? Do the sheer volume of extra power on the grid? Will DOE put pressure on grid operators to do their review quicker to support power uprates?
Testing. Is that working? Great. Well, Thank you for the question. I think, if you took anything from my remarks, for us, I do think there's aligned incentives across the board, right? I don't see it as pressure, right? I see it as, DOE has the power to convene. And I think, there's certainly, you saw the waterfall plots of everything that's on the NRC's books. And I think similarly across the entire ecosystem, you're going to experience a similar, right? There's a huge appetite, and everybody knows that we're not moving fast enough. So the answer is, yes, we're going to cooperatively and collaboratively work with the entire ecosystem, including the grid operators, including anybody who has an equity here to help accelerate getting gigawatts on the grid. We're committed to doing that. I think everybody is, at least from my perspective, aligned on moving fast. But instead of just saying, hey, you're moving slow, this is a problem, collaboratively means we're also helping to be part of that solution set, whether it's the technical work that our teams are doing across the national laboratories to include on the grid side of the house. We can do this together. And can I just comment? I know you said the R word. I've been adding an L word before it, which is the last Renaissance, which I find to be comforting.
And then on that same topic, maybe I can go to Tom and Chris, from their perspective, any work that you might be doing for those challenges that might represent adding the additional power to the grid.
I'll jump in there first. I think it's important to remember nuclear megawatts are one of many megawatts that are going to be added to the grid here in the next 5 or 10 years, right? The slope of the curve may vary a little depending on which region you're in, but the curves pretty much look the same for demand growth, over the next 10, 15, 20 years. So early conversations with the transmission, the grid operators are critical. And also, we talked a lot about collaboration. Collaborating what can be done to accelerate, what can't be done to accelerate, and then having flexibility with project schedules on both sides is key.
Yeah, my response will be more of a fuels-centric response, since that's my area. I will say, I'd like to think we're being pretty strategic at Southern Nuclear. The LTA programs that we've embarked on, the strategic kind of, thrust of that was that was going to give us real operational data to offset, we had mentioned accomplishing the uprates and not doing it reliably. In the fuel area, INPO wrote something, INPO 9602, I believe they wrote a follow-on, INPO 03-2, but it outlined the challenges you're going to face with your fuel, pushing the cores harder, increasing your power capacities. And so we recognize that if we wanted to do these things, these LTA programs were going to give us prototypic, in-pile, operational data under RCS chemistry conditions that we absolutely were going to need to ensure we could do these things in a reliable way. And so, I think we've got probably a pre-submittal meeting at the end of April with the commission on the second license amendment request for our Vogtle LTAs, which is the fuel product we will be using for the uprate at that plant. So I think those are really for us in the fuel area, the important things, and I'd like to think we've been pretty strategic. We've got the things in line we think we need to do that.
Going to move on to the next question here, and I think I lost it. This is one for NRC. Mike, maybe you could take it. Are there any discussions to find efficiencies in license renewal and EPU efforts to review applications together and revise Lake 109?
So we have not been in discussions about submitting together and reviewing together. However, we have been in discussions with licensees on their plans of when they were going to submit license renewal and EPU, and they could be very close or back to back, but not bundled together. So I don't know if you have anything else.
No, I think that they have different review focus, and I think that it's more efficient to review them separately. But we coordinate with those groups as well as we review them. But yeah.
And I'll chime in there if I can. Brunswick is a great example. We're going to be pursuing SLR. Reviews will be underway in similar timeframes as the MUR submittals, but again, they're separate, but we've coordinated between projects, who's going to do fluence, who's not, collaborated with the NRC. So again, I just wanted to give a licensee example, a real life example of that in work. Thanks.
And the comment on the lake and the update of the Lake 109, I think that question is coming across in the sense of the way that we are bundling and combining some of the LARs related to power operates. Industry might have a perception that Lake 109 might not allow for that type. We have been saying, yes, you can. They make sense to be combined. There are other places where you might not want to combine some applications because the differences that they have. We haven't updated Lake 109 at this point because we're trying to finalize all the guidance updates before we find efforts to put them in writing. But we have had those discussions through public meetings, and we have shared and put those in public meeting summaries so that there is some ways on how we have committed to allow for those type of bundling. All right, Chris, this one is for you. In the past, how the power operates impact reliability. Could you please elaborate on that?
So I'm not going to quote the various industry documents that are out there, but there is there's a novel of how uprates impacted reliability from the last time we did a large set of them. That's something I know when we are onboarding teammates and we're preparing to execute tasks, we go back and review those. INPO has a good library of OE there. The key really is, the willingness to learn from the past, and then as well, it was mentioned earlier in the week as well, INPO's got a strategic focus on this, right, as well. So they've stood up a projects organization that is going to be taking those lessons learned and coming around and ensuring industry is learning from them. So again, I don't want to get the cart ahead of the horse, but I know that's something that's been publicized, and there's data requests out there for that organization. So again, the real behavior is learning. We have a lot of first in a while, or first of a kind. When you look at just the folks executing, a lot weren't around last round of uprates. So really, it's taking that OE, utilizing it, and sharing it amongst the team.
Apologize, I had some issues with the tablet, but now we have this. All right. Additional questions here. This is for Mike. Is the agency preparing for super EPUs that can add more than 20% to the grid, including by adding second power conversion circuits? Do the industry panelists see any potential for that?
So I'd say right now, we are not preparing for the super power uprates, if you will, and we've heard from industry that all the uprates that we'll see in the next 5 or 6 years will be within the bounds, if you will, of previously approved uprates, where have been right around 20%.
Yeah, so we have interest there, not by the 2030 timeframe. The die is cast for that. However, there is work currently in progress through the DOE's Light Water Reactor Sustainability Program that we believe has the potential for significant promise to justify and really to help feed cost benefits and business case justifications for those superpower uprates. And so we are very interested in the outcome of that research being performed by DOE as we believe it's going to inform us on what we can and can't do.
The incremental costs will be important. Tom mentioned in his statements about cost to the consumer and reliability, right? So I really think, what if we can form the technical basis, can we form the cost benefit, and what's that incremental cost from the additional megawatts compared to other generation sources? Again, keeping the consumer in mind, low cost, reliable energy.
That's good. Dr. Baran, you're not. getting away too easy here. If the industry is scoping for their power operates, submitting applications and doing modifications, and the NRC does the review, what tangible deliverables is DOE actually delivering to support the power operates?
So we see kind of that's one piece, right, of acceleration is making sure that you have the technical case and go through the regulatory steps, right? That is certainly one piece. And I think for us, when we think about the word acceleration, right, again, we look at the bigger ecosystem. And so one of the questions is, if we want to move faster, there has to be a business case. So there's this techno-economic analysis piece, that we offer that takes into account the regulatory streamlining glide path that helps improve the techno-economic analysis, but it is ultimately pulling all those elements together and helping make that business case, and then being part of the conversation with the off-takers that are looking to, there is a huge appetite for new capacity, not just driven by artificial intelligence, but just load growth in this country. And so, we also understand, and I appreciate Southern's comments, right? They're in line with the president's direction, which is that, tech companies have to pay for their own way. We have to protect the ratepayer. So as we're looking to increase this capacity, building that business case with, by the way, while you're protecting the ratepayer, there's a lot of work that all of that happens after the regulatory piece that you mentioned. And so for us, we continue to support the regulatory technical work through the engagements that were outlined today, and all the way through that announcement and ultimately getting gigawatts on the grid.
All right, so the next question, I think this is Tom and Chris. I think you both alluded to, power operates are going to quickly get power into the grid, but also highlighting it is the first step and for the future of the industry and aiding construction. So we got a question here. Will the operate construction activities aid the new reactor builds in terms of meeting costs and schedules, and how that it's going to impact that?
I don't know. I don't know. What I think is, philosophically, if we set a standard through the uprate programs that we're going to hit our marks, we say we're going to do something, we say when we're going to do it, and we do those things, that standard, that expectation will flow down to the rest of the industry. We have a chance, to lead, and when you want to lead, you try to put your best foot forward. What better foot could our industry put forward than doing the things that we know how to do with the plants that have been operating reliably for the last 50 years. Capacity factors of the U.S. fleet are over 0.9 and have been for decades. Like, if you're going to put your best foot forward, let's do it with the uprates. Let's strike a tone and set the tone for the future of the industry.
Yeah, absolutely. I would argue if we don't learn, if we look back and say that we didn't use it as a stepping stone, then we missed a great opportunity. Again, this is our opportunity to show stakeholders how it's going to be done. There's, you could say that, public sentiment, stakeholder sentiment, investors, name a stakeholder, could make decisions about future nuclear based on what they see with uprates over the next 5 years, right? That's not a far stretch. So again, we should be using it across the industry, across the supply chain, to develop the muscle memory, improve processes, domestic supply chain capacity. If we're not utilizing it in each and every area to learn and to set the stage for new build, I think we've missed a great opportunity.
Can I just double click on that? I think that's well said, because I think we're the nuclear community, right? We appreciate technical and regulatory milestones for new nuclear deployment, right? You can get excited about a construction permit announcement. That's still pretty wonky stuff. You know what the public understands? When you announce, I've put more megawatts on the grid, right? That's something that is tangible. And so for us, when we think about putting points on the board as it relates to nuclear technology deployment, I can get behind technical regulatory milestones for new builds, but I think the public sentiment and support will be influenced by megawatts and gigawatts on the grid provided by uprates and restarts.
So I have another one here, and I think, Chris, this is said going to you, but I think, Tom, you can jump in as well. How do you compare the cost, the competitive cost of the power operates compared to the natural gas generation?
So they do compete, but it's an all and above strategy, I'll say, for Duke Energy. If you look at demand curves, there's not a singular technology that we can deploy that will get us there. So an all the above is our strategy, and nuclear is a key piece of that mix. Again, the business cases for us were competitive to add new megawatts to the grid, but again, it is those are looked at, right, from our Public Utility Commission to ensure that the dollars we're spending on generation capacity are spending the customers' dollars well.
I would just say we're also upgrading where it makes sense and where we can our natural gas capacities as well. So based on that, I would say that the nuclear uprates are competitive with gas and based on that.
Can I just add, and you know, my team has walked me through the spreadsheets, the detailed spreadsheets that show the total allowable costs, right, based on the specific uprates, and I think, you know, we also have an all of the above approach from a government perspective, and they are quite competitive. And this is back to the point about the techno-economic analysis, especially when you have off-takers that are looking to pay a premium, and now your LCOE looks a little bit more competitive. Not only are they cost competitive, we think doing them faster is also still cost competitive, right? And so I think I've been poured over the data, and I think not only is it cost competitive today, an accelerated version of what we're proposing is also very cost competitive based on what the hyperscalers are willing to pay.
Thank you. All right, Mike, I'm coming to you. So what is the NRC position on the potential reduction of technical content such as supporting calculation and that will be required to be included as attachments to power operates?
So I'll say, you know, licensees should be mindful of, you know, information submitted means, you know, staff review. So for example, if there's supporting calculations that are hundreds of pages long and they're only there to support maybe some statements that the licensee provides, those may be better suited available for audit versus providing pages and pages of information that, as a reviewer, if you don't know what it is and why it's provided necessarily, you would have to go through it. So I would just be mindful, and I would think some of those could be sorted out at pre-application engagements to figure out exactly why licensees are going to submit it and what they're going to submit.
And a follow-up to that question is, this moved. Can you talk about the type of inspections that will be completed as part of power operates?
So we do have an inspection manual specific to power operates. I don't know exactly what those inspections entail. I know some are regarding power ascension, but there is an inspection procedure that specifically talks about and these are for EPUs. It's over, you know, a certain percentage. So these apply to EPUs mainly on what kind of things are looked at. But we do have an inspection manual, and I know that that's something we're looking at. Are there any maybe efficiencies we can gain with maybe revisions of that potentially? So.
All right, Dr. Baran, this one is for you. Can you comment on what, if any, funding path, loans, tax incentives are under consideration to perform power operates?
Yeah, one of the reasons I mentioned the Energy Dominance Financing Office, right, is because you know, not only are uprates eligible for loans, for low interest loans. You know, we're seeing, you know, kind of disbursements already from EDF. There was a pretty significant one for Southern that was announced recently that does include uprates. And so for us, you know, that's an important mechanism that is not just available but has been used, and there's an important precedent there. So, you know, we have been using our R&D dollars to really support the acceleration of the business case. And then we have the loan program that allows the investments needed.
And I don't want to speak for DOE, but I'm aware that there are other tax incentives out there, not through DOE, but through the things that the government has done to provide some incentives for the industry to consider power uprates as well.
Of course, yeah. I think, and I'm not a tax expert, but I think the ITCs apply. They apply to uprates. When we look at when I said I poured over the business case, I mean, the analysis that these folks do, it takes into account the tax credits. And then it can take into account the loans provided by EDF if that's what they wish to pursue. They may be able to get loans from other parts of the banking infrastructure. So to me, the tax credits that are available are kind of baked in when we think about the costs, but absolutely.
All right, Chris, this one is coming for you. So what advice would you give and what actions would you take to ensure plant reliability isn't sacrificed when licensed thermal power is increased?
That's a great question. A division of responsibility, I think, is important, right? Again, I mentioned, and there's various setups that you can use, but essentially, our organization we view as a supplement to the existing plant staffs, and we're really there to allow them to focus on their job of running the plant reliably today while we take care of the strategic projects. So again, that division of responsibility and then how you set up your organization, I think, is a key foundational block of how you can start with that culture. The other piece, and these at times can be conflicting priorities, right? But how do you get the right subject matter expert reviews? How, when you know the person in the plant that owns the system engineer, is the right person to do that critical review because of their expertise? How do you package it correctly such that you can minimize their time, still get a great review, but not distract from the operating unit? So again, those are just a couple strategies we're utilizing, and I think are keys for ensuring quality when we come out of this. We actually do achieve the increased capacity factor across the entire fleet because reliability is still high.
Tom?
Yeah, I'll say, I agree with what Chris said, and another kind of dimension that's part of our processes. It's very methodical. We employ through our vendor that I believe we're going to use for the uprates, a multi-phase approach. One of them, like Chris had indicated about finding your system owner, the phase one involves what we call an expert panel, where folks go to the site, interview the system engineers, find out where the pinch points are. They bring that back, take those interviews, take the results of those discussions with the SMEs on the systems. Then they ping that off of their OE database from the 170 however many uprates, there's only 100 operating plants, right? But the numerous uprates that were done from the 90s on to say, hey, these systems, were they pinch points, what issues, what OE, and then INPO. The INPO guidance, as Chris alluded, I know in fuels there's multiple, but that's for every aspect of the plant operation. And so, leveraging that guidance and the lessons learned from the last wave of uprates is also extremely important.
Awesome. All right, so the next question is, we all talk in different aspects of the use of AI, and this question is on that. So, of course, AI can be tremendous potential to improve efficiency, but how can we ensure responsible use, especially in the high-stakes environment in which we operate? How can we balance the benefits without increasing risks that arise with potential AI-induced errors as we try to move faster than even before? Moreover, how can we ensure that we don't degrade human knowledge due to dependence on AI?
I'm happy to start. We think about that question at the Department of Energy because for us, as I mentioned, we actually think that AI can be transformational, not just for licensing, but we actually think it can help with design, licensing, manufacturing, construction, and operation. We actually think that a world where you get to agentized workflows with humans in the loop across the board, where those are not just agentized workflows working in silos, but you can imagine the AI agent that's doing the design is talking to the agent doing the licensing that's then going to manufacture the part that helps the person doing the construction, right? This is when we talk about more than just an uplift, but a transformational approach to workflows. And in all of those cases, humans are in the loop. Right? The idea here is it's transformational because you're not just kind of removing administrative efficiencies, you are taking advantage of agentized workflows that have the ability to do reasoning. But the big question is, how do you do the V&V, the validation and verification? And it's going to be important. It's going to be important for the regulator. It's going to be important for the operator. It's going to be important for the vendor. It's going to be important for everybody to understand that those workflows are at least as good, but what we expect to be better than just workflows from humans, because humans will be in the loop, but they will have the benefit of working with, frontier AI capabilities that have been fine-tuned and trained on exquisite data. I think AI sometimes, gets a bad perception, because if you just go and download ChatGPT and ask it a lot of questions, you will get wrong answers very quickly. Right? But to me, that's kind of like, grabbing somebody from 7-Eleven and asking them about uprates and licensing. You're going to get hallucinations if you force him to answer you. It's not a trained individual, right? It took, I'm not going to ask how old you are, but it took many years for this person to be educated and fed to get to the point where he can actually contribute intelligibly to human workflows. It's the same thing for AI agents, right? There's actually a cost of training, and so we think about this. We do believe that it's going to be hard, but it's absolutely doable. And the good news is that we don't have to just figure this out for the nuclear domain. I mentioned earlier the Genesis mission, which was directed by the President to the Department of Energy. It's our most ambitious R&D activity in this administration. And what it does is it tells the Department of Energy to pick at least 20 challenges of scientific importance to the nation. With fission, by the way, being one of those at least 20. We ended up with 26, but fission, fusion, semiconductors, quantum, picking these domains. And the idea is that we're not just saying, hey, throw Copilot to help with licensing and let's get out of the way. The idea here is that how do you build a platform with the singular scientific data sets that we have in government and industry, and how do you take that infrastructure, take the data, bring the experts, and actually try to create those workflows that transform those different challenges of scientific importance. We have one on nuclear that we're really excited about, and licensing is just one sub-element. So the point is, a lot of people are thinking about this, right? Nobody, I know the stakes are really high. Nuclear safety is paramount to all of us. But the transformational opportunity for all those other domains is driving a similar approach to ensuring that there's verification and validation for those types of workflows.
Yeah, I'll just add, when I think of this question, responsible use, my mind goes to risk. And what one could argue that the skills that we develop in this industry, the standards that we have, there may be no better folks to determine risk, box in the risk, and come up with preventative measures than those in the nuclear field, right? It's what we do every day. Every decision is risk-informed operating a nuclear power plant. It's no different with these strategic projects such as Uprates. So I think about finding the right risk box now for AI. We're just scratching the surface at this point, right? We're not even to a point where we can utilize AI to its fullest potential for things such as optimizing schedules and laying out, think more kind of administrative tasks, but there's great benefit there. So it's boxing in the risk, the human in the loop, but really I think we're so early on now with even utilizing it again for really low risk administrative tasks that this is it's an area that there needs to be focus on, but by the time that ability exists to make technical decisions, I have confidence that we've got the right folks working on it. We'll have those guardrails and those platforms in place.
Yeah, I would agree with Chris and both Dr. Byrne. AI, it is in its infancy. There's a lot of applications emerging. There are some historical applications. I learned a few months ago that eddy current inspections on steam generators contain neural networks. Some of the decision in the eddy current inspection. So it's been used. That's going back 20 years. We use neural networks to try to understand what happened at Fukushima. Random forest, moving trees algorithms to do that stuff. So it's we called it machine learning. So now we're calling it AI, but fundamentally, and the large language models may be a little different, and those are the things we're looking into, but they're not, I don't know of any instance where those are making decisions about plant operations or what we do. They're informing us. We're using AI to look at moisture carryover performance at Hatch, but it's not changing how we evaluate moisture carryover. We're still using the tried and true methods for evaluating moisture carryover, but we are undertaking the burden and the labor to get those models trained. And maybe one day, we will have that discussion where they are being used to make formal decisions. But I also agree with Chris that we're going to have the guardrails in place. It's going to have a long track record of demonstrating performance before I think we would entertain discussions like that. But there is, we believe, significant potential for efficiency and streamlining improvements through the use of AI, the AI tools. And so we think it's something we need to invest in investigating and getting that to a level of maturity that we can I guess, reap the benefits of that.
And from the NRC perspective, I think earlier this week we had a session on the use of AI, and the main message there is to be responsible, very deliberate, and maintaining the human in the loop. And I think that you all touch on each one of those criteria to make sure that we're using AI in the best possible way. All right, I think that we're coming to the end of this session. I wanted to, first of all, thank the panelists here. I think that what you have heard today here is an effort that we have been working together for the last 2 years to make sure that we're ready to deliver. I think we all share a common goal to provide reliable energy to the grid quickly as we can. And the key here has been each one of us have an independent role, but we have been collaborating to make sure that we achieve that goal. And I think that we are ready. We will meet the demands, and we look forward for what this year is going to be. Next year, Rick, we're going to be in the middle of many applications and looking forward to getting there. So thank you again for everyone for your support, for coming here and talking about each of your views and areas to support this effort. So thanks.